Hello, YouTube viewers. Welcome to my show, Science to Thursday. In today's episode, we're going to talk about water technology. So let's dive right into it. Now, first thing, which does not require mentioning, but I'm going to mention it anyway. It's a big problem. Basically, it's not a luxury. We have to solve it. Otherwise, we're going to be dead in 3 days. So it is something that we have to solve it. After that, the one good news is we have the technology. Like, it's not a matter of like, oh, we don't know how to solve it. No, we know how to solve it. It's not like global warming. It's not like some complicated issue like cancer and all that. We know how to solve it. However, there is one critical side effect, is that there is no one solution. Like, there are like you need a toolbox to solve this problem. You don't have like, okay, this is a hammer, all problem is solved. It's not like that. So, and where are we going to tackle this problem now? If you want to live in earth, if you want to make sure that entire humanity does not go crazy, you have to fight it on multiple fronts. Basically, you have to fight it in the cities, because tool required to solve city issues is completely different what you would require for villages. That would be completely different tool set you're going to need for industrial sector. So you have to understand this. Like, that is why we cannot utilize one tool to solve all the problems, and we have to tackle it on multiple fronts. Thankfully, we have the technology. So first, simplest technology is rainwater harvesting. Why it's illegal in some parts of America? God help you. God help you if that is the case. But again, it is very simple and it is very cheap compared to every other option. It is dirt cheap. And to give you a context of it, I have provided a link down below of a guy who did literally lives off of rainwater itself, and it's in a desert. So you have to understand that it is very cheap and easy, relatively speaking. And when we are talking about turnaround, this is a very critical thing, because if you see the bill, like if you see the bill like small every month, you don't notice it. But when you're talking about like, okay, big jugs you have to buy, or big water tanks you have to buy, it's very expensive. But if you are talking about turnaround time, okay, I invested in this technology, I invested in this, how long it's gonna take me to recoup my investments? It's very quick. And there are some villages in India that suffered from serious water droughts, and somebody with intelligence came around. It's like, okay, let's do rainwater harvesting. They solved the village level drought of 10,000 people plus in 1 year. So I have to understand it, like but there is a one serious consequence to this. It is monsoon dependent. Now when I'm talking about India, I'm talking about like very big big monsoon seasons. Like in olden days, we used to have like 2 whole month of monsoon season. We like have festival here which lasts for 1 month, and it's like we call it Sawan. So like it's a like 1 month long festival, and it rains continuously. So you have to understand, it is monsoon dependent. I cannot ask this about like in Sahara desert, it's not gonna do much, or like in some other, but most places where humans are, generally it rains. So it does have quick turnaround. It has very cheap in terms of other, compared to other tools, it's like dirt cheap, and it's easy. It does not require you to have PhD and on top of other PhDs. So this is rainwater harvesting. This is first tool that we can employ. Second tool, now this tool is water recycling. Now if you have been following my entire video catalog of past few weeks, you must have understand, like there are many ways to do it. We can use ozone, we can use chlorine, we can use ultraviolet. There are many tools we can employ to take care of water recycling. Now problem with this is ludicrously expensive, and it's complex. It's not a simple system, it's a complex system. Basically everything, every stage you have in a sewage treatment plant does something very specific. And but it does come with one good effect. It is location independent, because no matter where does human live, people gonna produce waste, people gonna produce liquid waste, so you can recycle it. Like, it's not location dependent. You have people, you have waste. So you can literally think of it this way. This is omni processor from Bill Gates. You can check my video about that here. Is that, and it just takes a human sewage and turns it into drinkable water. Now this also has another benefit. Like, let's say you have other water source like groundwater, river, or whatever have you, rain itself. It reduces stress on those systems, because you can't do 100% water recycling, because even if you have a completely controlled environment like International Space Station, you can only recover upwards of 90+%. You can push it to 98, but let's go with 90. Now here's the reason why ISS can do that and no place on earth can do that, is simply because ISS is airtight. So you do not suffer any loss from evaporation. That's not the case in case of earth. So if let's say a city is drinking let's say 1 billion liter of water, you're not gonna get 1 billion liter in terms of waste, or not even like 0.9. You're gonna get like, if best case scenario, 0.5, simply because a lot of that water would be evaporated, like when you're breathing. So if you drink water, and you breathe out, your lungs is like, dumping a large amount of water vapors. So you are losing water that way also. It's not that only urine is the way. And if you sweat, that also evaporation loss. So you have to understand, we don't expect recycling in terms of like, okay, we're gonna have 100% recycling. No, that's not happening. But you can reduce stress on the system, and it does work. Like, and it's location independent. Like, you have a large group of people, you can utilize this system. Right now there is no tickle about it. However, it is complex and expensive. So this is another tool in our toolbox. Now this is the grand hammer, the desalination plant, because you have to understand this. It is very expensive and it is power hungry. To give you a context, Dubai start to utilize this in early 1990s, and they had problem with it. Basically, the amount of oil this puppy used to drink up the power plants, that there was like a power plant just for this. So understand that it is ludicrously power hungry, and in terms of money, it is expensive. However, due to advancement in RO technology or reverse osmosis, you can check my detailed video here, this has now come down considerably. Basically, it went from requiring freaking nuclear reactors to keep running it to, okay, something we can tangibly do. So, and it is location dependent. So you have to be talking about a coastal city, because if you might think, hey, what if I take water from a canal, dig a canal from sea to wherever my city is, or under wherever it is located. Problem is, canals, unless it's ludicrously deep, the water will be simply evaporate. So China did try that. They did try to, like, from Himalayan, they had a lot of water flooding issues. So they did wanted to, like, on a coastal area where there is water shortages, they built the whole canal system. Like, canal system was built, but the water evaporated. Water never reached there. So you can't just solve the issue unless you are using pipes. If you are using pipes, you can send it wherever you want. So it is location dependent. However, it is an infinite supply, because Earth's gravity is strong enough. We're never gonna run out of water, and seawater will be always there. Like, you don't have to worry about it. So at this point in time, Israel is leading the way. Why? Well, again, Israel suffered a very serious water crisis in early 2000 to 2010. Like, they were suffering. Now their mindset changed. They went all in. So they went in 3 core steps. Core step number 1 was conservation. Basically, don't waste water. That was step 1. Step number 2, drip irrigation. Now this changed the whole landscape. They went from, like, consuming, let's say, 1 billion liter to like 500 million liter just on agriculture alone. That's a lot of amount of water, and that also saved them. Other benefits was also there of using drip irrigation. So they got extra bonus from that. On top of that, they invested seriously into RO membrane technology, because many other countries did try, like, heating the water, and it does work. It's a completely normal way to get distilled water. However, the problem is it's energy intensive. So their investment in this, they took like 15 to 20 years to build this kind of foundational understanding in society, understanding in, like, infrastructure, that they can do this. Now once they have done that, at this point in time, they are water rich. So basically, they do not have to worry about water. Like, they are not in a place where, like, oh, drought will happen. They are like, I got this. They are so water rich at this point in time that they actually, because they have very, very problematic relationship with their neighbor, they are like, chill, we're gonna give you water, because they can. Like, they are that water independent, and that's all because of this desalination plant. To give you a context of how water, what scale of water we are talking about, these sort of plant are never measured in liters, because it will be too big. The number will have too many zeros. So they will generally say 1 cubic meter. That will be the unit. So they say one unit, that's 1 cubic meter. So 1 cubic meter has 1000 liters. So they generally give you price, like, I'm going to build this plant, this is the price that you have to pay of drinking water. Do understand that it's not a water that you will use for basically you can take bath with it. That's not an issue. It's a drinking grade water. It's like a completely 100% human safe water. It's 0.6 dollar, basically $0.50, and it is per 1000 liter, and that's drinking water. So at this point in time, if you have drinking water issue, it's like you have dirty water to take care of. Dirty as in, like, maybe contaminated with some iron, magnesium, or things of that nature, that makes it bad for drinking, but it is more than good enough for washing clothes, other things like that. You can buy this right now and you won't even notice it in your monthly bill. However, this price is not for you, it's for the municipality. But again, even Florida has already started investing in this technology, because this does solve the issue. It's not like, okay, we're gonna do this and it may give us some year, because once we figure out even more efficient system, once we figure out even more long lasting membranes, because membrane right now they only last for 10 years, so they want to make sure the membrane lasts for 25 or 30 years, then the return on investment would be much better. And California started it, so I'm pretty sure other states will soon follow, because this does solves it. It's like if this technology pushes to like upper limit, we're gonna have a generation of people who will never worry about like water, and that's a good thing. Now, what about the brine that is ejected from the RO plants? Generally, they are not working at very high concentration. So, like you can have a scenario where you take, let's say, basically 100 liter and purify 90 liter, or you can have a RO system where you take 100 liter and only purify 50. These plants are only refining 50. The reason for that is the brine becomes basically less. Less toxic, so they can dissipate in sea without causing too much damage or any damage, because if the it's distributed far enough, it does not make a difference. They have tested, and these plants have been going on for 10 years, so it's not like we are okay for today we did this. No, 10 years of data is there to back it up that it will not kill fishery permanently. So, and what if there is side effect? Again, this is what nature does. Nature, like when evaporation is happening, this is exact same thing. So overall, in overall scheme, this solves humanity's problem. It's like this combined with rainwater harvesting, combined with water recycling, we will never ever have to worry about water shortages anywhere on the planet, because this water cost is quite cheap. So this was my presentation on water technologies. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, and if you are disappointed by it, please click the dislike button. I would urge you to press it twice to show me your extra disappointment. And please leave a comment, because I reply to all of them. And please check my all these other videos and subscribe. Press the bell icon if you're free. And as always, thanks for watching.